Properties of vector under rotation. In this question, we will show that the components of a vector may change under rotation. Suppose you have a r vector, the position vector, the r vector, and position vector r vector is in 3 dimension, and the vector r have component x component, y component, and z component. Suppose the vector r rotates counterclockwise or anticlockwise. So consider the counterclockwise rotation of the vector r about z axis. So the x axis and y axis that will change after counterclockwise rotation, but the z axis remains same because the vector r is rotating about z axis. Suppose after rotation the x axis becomes x dash or x prime, and y vector suppose say is equal to y prime, but the z vector this will remain same, that is z vector will be equal to z prime, and r vector has been rotated suppose through an angle theta. And here we will show that how the rotation of the vector r affect the coordinates, that is x coordinate, or what is the relation between x prime coordinate and x prime coordinate and xy coordinate. Similarly, what is the relation between y prime coordinate with y or x coordinate, we will discuss here. Suppose after rotation x coordinate will be equal to x prime coordinate, and you draw a perpendicular AC from A to C, and you take a parallel vector CD to the x prime vector, this vector, and you draw a perpendicular here from P to C, and you draw a perpendicular PD. Okay, so you have a right angle triangle. You see, you have a right angle triangle, that is the right angle triangle OAC. If you draw a perpendicular here AC, then you will have a right angle triangle OAC. This is the angle theta and this is the right angle. So from this right angle triangle OA, you see OA will be equal to x cos theta. Similarly, you draw the perpendicular CD. I have told you, you draw the parallel line CD with the x prime, this line, AB line, and you draw perpendicular PD. You see, you draw perpendicular PD and you join PC. If you join PC, that means this PC is parallel to this y vector. You see, this PC is parallel to this y vector. Then what will be CD? You see, in this right angle triangle, then what will be CD? CD will be equal to, you see, this will be y sin theta. This CD vector will be equal to y sin theta, and CD will be equal to AB. This CD will be equal to AB, which is equal to y sin theta. So you have OA will be equal to x cos theta, and CD, which is equal to AB, that is equal to y sin theta. So you can write x dash. You see, you can write x dash, which is equal to OA plus AB. So OA we have found out that is equal to x cos theta, and CD, which is equal to AB, that is equal to y sin theta. So you can write x prime is equal to x cos theta plus y sin theta. So you write the equation x prime is equal to x cos theta plus y sin theta. So you see, after rotating an angle theta, how the x coordinate will change. the x coordinate will be equal to x prime. That means x prime is equal to x cos theta plus y sin theta. So x prime is related to both x, y and theta. Now we'll see how the y coordinate will change after rotation. Now you draw a perpendicular FG. So you have a right angle triangle FPG. This angle is theta. So in this right angle triangle FPG, what will be AFG? AFG will be equal to x sin theta. Is not it? Because you see FP, which is equal to x. This value is x. So x, this value is x, this is theta. So FG in this right angle triangle, FG will be equal to x sin theta. What will be OE? You can find out the value of OE. You see, this is a right angle triangle. And in this right angle triangle, you can find out the value of OE. OE will be equal to y cos theta. Is not it? Because you see, this is your y value. This is your y value and this is a right angle triangle. So FE will be equal to y cos theta. Then what will be OH? You see, what will be OH? You join this line so that you will get OH. So OH will be equal to OE minus EH. Okay. And what will be EH? EH will be equal to FG. And what will be FG? FG is equal to x sin theta. And what is OE? OE will be equal to, you see, OE will be equal to, we have found out y cos theta. So what will be EH? Okay. What will be OH? OH will be equal to OE minus EH. OE is equal to y cos theta and EH is equal to x sin theta. So OH will be equal to OE minus EH. But what is OH? You can write OH is equal to y prime. So y prime will be equal to y cos theta minus x sin theta. So you can write FG is equal to x sin theta, OE is equal to y cos theta. So OH, which is equal to OE minus EH, OH is equal to y dash or y prime, that is equal to y cos theta minus x sin theta. We have got x prime is equal to x cos theta plus y sin theta, and y prime, we first write x component, so minus x sin theta plus y cos theta. So you see, after rotation, the coordinate will change. So you can write this in matrix form. So if you write it in matrix form, you see the z coordinate will not change. The z coordinate, that will not change. Z prime will be equal to z. So how you can write this in matrix form? In matrix form you can write x prime, y prime, z prime, that will be equal to, you see, that will be equal to, from this equation you can write, you see, from this equation you can write cos theta, sin theta, and z coordinate is 0. Similarly, minus sin theta, your cos theta, z is 0, and for z coordinate you have, for angle it is 0, 0, and for z prime value it is equal to 1, because z prime is not changing and non-prime coordinate is x, y, z. So this is the matrix form. This equation you can write in matrix form like this. So you can write r prime, this term you can write r prime, which is the position vector after rotation, that is equal to r theta. This term is r theta into your position vector r. So r prime is equal to r theta into r vector. And what is r theta? You have to remember this. R theta is the transformation matrix or rotation matrix. In the examination, you will ask question, you write how the position vector will change after rotation. In terms of matrix, you have to prove it. The position vector after rotation will be changed in this form. That is r prime is equal to r theta into r vector. And in the next video, we will see or we will verify whether the magnitude of the vector will change after rotation or not. Okay. After rotation, the position vector is changing, but the magnitude of the position vector after rotation, it will change or not. You have to prove it. You will prove in the next video. So you remember the magnitude of the position vector will not change after rotation. After rotation, the position vector will change, but the magnitude of the position vector, that means the magnitude of the vector r will be equal to the magnitude of the vector r prime. The magnitude will remain same, but the vector will change. And how they are related, you have to prove it. The relation is r prime is equal to r theta into r, where r prime is the position vector after rotation, r theta is the transformation matrix or rotation matrix, and r is the position vector. This is a very important question.